Good evening to all. Today we are going to take another topic, which is basic selection criteria of hydrodynamic bearings. So in this video you will learn how the bearings are selected and what are the criteria for selection. So first of all, as I said, you need to know, or you need to select the bearing or compressor frame size. So how first once frame size selected, then only you can select bearing. In fact, moment you select the frame size of compressor, bearing is automatically selected or chosen, and then criteria is applied for validation. So first of all, compressor frame size selected based on the inlet condition. What are the inlet condition? Inlet condition means pressure, temperature, gas compositions, relative humidity, and flow. So once an inlet condition is dependent in inlet density is dependent on inlet condition. Why? Because if inlet pressure is more, density will be more. If inlet pressure is a low, density will be low. Similarly, inlet temperature is a high, density will be low. If inlet temperature is a low, density will be high. Similarly, gas composition is more denser, density will be more, and vice versa. So density is dependent on inlet condition. And what is inlet actual flow? Inlet actual flow is equal to mass flow divided by density. That is why it is written, if the inlet density is lesser, inlet actual flow will is more, because density in mass divided by density. For the fixed mass flow rate, so selected frame size of compressor will be larger if inlet actual flow is more. So if you consider two cases where mass flow rate is the same but inlet condition, that means densities are different, the frame size of compressor will be more where inlet density is lower, because inlet actual flow will be higher. So this is how stages compressor frame size selected. So larger the inlet density, inlet actual flow, larger is the frame size of compressor. So smaller is inlet actual flow, frame size will be smaller. So this is one criteria for selection of compressor frame size. So but once then compressor stages are decided based on additional information of compressor discharge pressure, because if you know the pressure, overall pressure ratio, final discharge pressure to inlet pressure, so if this ratio is very large, you need a more stages compressor. If it is lesser, then less number of stages are required. So once compressor frame size selected, bearing type, bearing size, and speeds are chosen as per manufacturer's standard. So these are already standardized things. So larger the frame size of compressor, selected bearing will be larger, but the speed will be lesser. Similarly, for a smaller frame size of compressor, bearing size will be smaller, but the speed will be higher. So let's understand. So now bearing is selected. What are the criteria for validation? So these are the basic selection criteria for bearing. So it has been divided into two sections. One is for general bearing, then selection criteria. Another is a thrust bearing selection criteria. So first criteria is length upon diameter L by D ratio. This is general length and this is general diameter. This is section of bearing. So this ratio should be closer to 1. Then this is just for reference. It can be different, it can be less or more, but this is for reference. Criterion number 2, general bearing surface speed should be less than 106.7 meter per second. And what is this? This is pi d n by 60, where the d is a diameter of the journal, n is the speed of shaft. But if you talk about the relative speed of bearing is the same as the speed of the shaft. So that is why pi dn you can use this. Third criteria is a specific load, which should be less than 24.8. What are the specific load? there are various type of load acting on the bearing. Like one type of load is a shaft mass itself is a one load, then attachment to the shaft is a impeller attachment is another type of load, then coupling attachment is another type of load, and sometimes shaft is driven by geared mesh, and which is generating more forces on the bearing. So all these are forces needs to be calculated, and all the forces on the radial direction is the radial force on the bearing divided by projected area of journal, that is L into D. So this is called a specific load. So a specific load is radial load divided by projected area of journal, that is L into D, and this should be less than 24.8. Now coming to the thrust bearing criteria, which is again thrust bearing surface speed. You have to take, there are the two inner diameter and outer diameter of the thrust faces. So you have to take the base, and then pi d n by 60 you have to do to calculate the thrust bearing surface area, and should be less than 198 meter per second. And a specific load, which is a thrust load divided by area. So thrust load is axial load acting on the bearing. So how to calculate the axial forces, you can refer my video which is available in my channel. And what is the projected area, you can use pi by 4 ds d to outer diameter square minus inner diameter square. So if you divide axial forces divided by this projected area, this will give the specific load, and it should be lesser than 24.8 bar. So this is same number. A specific load is 24.8 bar for general bearing, and even the thrust bearing also specific load should be less than 24.8 bar. So these are the general criteria for selection of the bearing or validation. Let us understand with an example. This is a radial forces, vertical forces acting on the bearing. These are the axial forces. So refer the picture on the right side having the following details. The journal and thrust bearing details are given. Bearing journal diameter 75, bearing journal length 75, thrust bearing inner diameter face 80 millimeter, thrust bearing outer diameter face 125 millimeter. Radial load on each bearing is 6000 Newton. Axial load on each bearing is 8000 Newton. If the speed of the shaft for these bearing is 12,000 rpm, validate for acceptability. So now journal bearing validation. First we will do the journal bearing validation. So L by D ratio criteria is 1. So bearing length, journal length L is 75, bearing journal diameter D is 75, so ratio L by D is 1, so which is okay. Now the next criteria is surface speed criteria. So journal bearing diameter D is 75, journal speed of shaft or bearing, as said, is 12,000 rpm. So bearing journal surface speed pi dn upon 60 divided by 1000 because diameter in millimeter. So if you calculate this, it is coming 47.1 meter per second. So journal bearing surface speed is less than 106.7 meter because it is only 47.1. So that means it is acceptable. Now the another criteria, that is specific load criteria. So bearing journal length DL is 75, bearing journal diameter D is 75. Radial load on each bearing is W1, this is 6000 Newton. So journal bearing projected area A1, L into D, so 75 into 75, this is this number 5625 millimeter square. So if you want to convert, it is coming as 0.005625. So specific load is equal to journal radial load divided by projected area, which is 6000 divided by this number 0.005625, which is coming as this number Pascal. So if you have to convert in bar, you have to divide 10 to the power 5, which is coming as 10.7 bar. So specific load is 10.7 bar, which is less than 24.8, so it is acceptable. So this is validation for journal bearing. Now coming to the thrust bearing validation. So surface speed criteria, thrust bearing inner diameter is D1 80 millimeter, thrust bearing outer diameter is D2 100 25 millimeter. So thrust face average diameter is summation divided by half, which is coming as 102.5 millimeter. Bearing thrust face speed, bearing thrust face surface speed pi d average into n into pi d average into n divided by 60 into 1000 divided because in millimeter. So if you do the calculation, it is coming as 64.4 millimeter per second. So thrust bearing thrust face general speed or thrust face speed is less than 106.7, and this is only 64.4. So this is acceptable. So thrust bearing surface speed criteria is acceptable. Now specific load criteria. So thrust bearing inner diameter D1 180 millimeter, outer is 125 millimeter. Axial load W2 is 8000 Newton. So thrust bearing projected area E2 is 5 by 4 D2 square minus D1 square. Putting all the value, it is coming this millimeter 7245.3 millimeter square. So if you want to convert meter square, it is coming as 0.007245. So specific load is equal to axial load divided by projected area A2. So 8000 divided by 0.007245, which is equal to this number Pascal. If you want to convert into bar, divide by 10 to the 5, which is 11 bar. That means a specific load is 11 bar, which is lesser than 24.8 bar, and so this is acceptable. So this is also acceptable for thrust bearing. So I hope I have explained some basic criteria for selection of this journal bearing and thrust bearing. So basically, first you have to select the compressor, and once compressor is selected, then based on manufacturer's guideline, a standard bearing is selected. So if frame size of compressor is larger, bearing diameter will be larger, but the speed will be smaller. If frame size compressor is smaller, bearing size will be smaller, but the speed will be higher. So once bearing speed and diameter is selected, then you have to validate for condition. These conditions are for general, it is L by D ratio, and another is surface speed, and third is the specific load. Similarly, for the thrust bearing, it is a thrust face thrust face surface speed and a specific load. So criteria is met, then that means the bearings are acceptable. So hope you have enjoyed this. So thank you and see you in the next video. Thank you.